back, and so now you're going to go to PhET, and this time you're going to find PhET John Travoltage on the internet. And then when you open it up, you'll come to a picture that kind of looks like this. And so I've already done it for you here. And so there is the simulation. Now in the previous simulation, we explored non-conductors. So in a non-conductor, the electrons were not free to move through the material. But in this simulation, the electrons are going to be free to move through the material. All right, so we're going to grab John's leg here. Oh, and you want to make sure and turn on the sound. It's very important that you turn on the sound for this one. Okay, and then we're going to take his leg and we're going to move it back and forth. And what do you notice? Okay, and then do you see that they're blue, and what's the charge on them? Okay, so you should know what those things are. And then can you figure out where did they come from? Okay, so that he charged himself up by taking his leg and rubbing it on this. So do you want to take a guess? What do you think that this thing is made of? And then what do you think the bottom of his foot? He's wearing blank shoes. And so then that was rubbing off electrons off of this substance, and then it was going into his leg. But do you see how this is different than the balloon? So that the electrical charges are free to move through his body because he is a conductor. Okay, then the next thing that you're going to do is you're going to take his hand, and you're going to take his hand and then point it at the doorknob, which is made of what substance? Okay, and then you're going to see what happens to all of those electrons. And John is going to get shocked, okay, because he is, okay, now if we go back to the lab, okay, you're going to be answering these questions. And I already have given you part of the answer. So he's going to shock himself because he is, and it starts with a G and then ends with edited. He G'd himself. So what would that be? So if you don't know, you can probably find that on the internet. And he allowed those electrons to travel through his body, come out his finger, and then travel into the doorknob. And so that's the reason why he got shocked when he did that. All right, now we've got some post-lab questions here that you need to answer. So what is the purpose of the lab? Well, that's pretty easy. So all you got to do is go all the way back up here to the top where it says purpose, and then copy and paste. So you don't really need to write it out if you don't want to. So you can just copy and paste and put that in here. Make sure and do it in red. And then how many different types of electrical charges are there? And then what's the names of those electrical charges? And then what's the names of the particles inside the atom that produce those electrical charges? Okay, then it talks about what happens when you have a positive and a negative charge, two negative charges, two positive charges. So how does the force of electricity differ for those different situations? Okay, explain what is a field. So a field in general. If you want to talk about the electric field or the gravitational field, you can, but I just wanted to know what is a field in the first place. Okay, then the next one, what does conservation of electric charge mean? Okay. Okay, so the next thing says if you take cat fur and you rub it with a glass rod, which one becomes positive and which one becomes negative? So go to that chart that I showed you and find out which one tends to become positive and which one tends to become negative. Okay, then this next one says that two charges are a certain distance apart and they have a certain amount of electrical charge on them. And so now what we're going to do is double one of them in charge, and then the other one becomes 3 times greater. So one of them becomes 2 times greater, the other one becomes 3 times greater. What would be the new force? And so remember that the Q1 and the Q2 are next to each other, so that's multiplication. Q1 times Q2. And then for question number 8, now we're not going to change the charge, but we are going to change the distance between them. So if the distance between them increases by a factor of 4, so R goes from being R to 4R, then what would be the new force of electricity? So I'm actually looking for a number. All right, so you have just accomplished your first lab in physics. Congratulations. All right, so we're going to call it quits for today, and then the next lab that we're going to be doing is going to be on magnetism. So I will see you then.